Good afternoon. Our today's topic is radio communication. Depending upon the channel used, there are two types of communication, mainly wired communication and wireless communication. In wired communication, communication is achieved by coaxial cables, pair of wires, or optical fiber cables. In wireless communication, or another name for wireless communication is radio communication, electromagnetic waves are used for communication. The main advantage of wireless communication is possible over larger distances, even from Earth to Moon. This is a block diagram representing the radio communication. This is a microphone. This is radio transmitter. This is transmitting antenna. Another one in the receiving section, receiving antenna, radio transmitter and a loudspeaker. We know that mic is a device which converts voice to electric signals. These electric signals are converted to electromagnetic waves using a radio transmitter. And the radio transmitter transmitting these signals through a transmitting antenna. And in the receiving section, the receiving antenna receives the signals by proper tuning. And we have a radio receiver converting the received signal back to electric signals, and it is reproduced in the loudspeaker section. In the previous class, I have taken a topic that is modulation. Today we are discussing amplitude modulation. So what is modulation? Modulation is nothing but it is a process of changing some characteristics of the carrier wave in accordance with the instantaneous amplitude of the modulating wave. That means the information signal or the informations we are getting. These are the properties of information signal. Information signals are low frequency signals, or another name for information signal is modulating signal. So this modulating signal or low frequency signal or the information signal is added with, or it is superimposed into a high frequency signal, that is the carrier signal. This is the frequency range of carrier signal 530 kHz to 1600 kHz. So the low frequency signal is superimposed into a high frequency carrier, gives modulated signal. Okay, that is the definition of modulation. That means some properties of the carrier wave. Properties means amplitude, frequency or phase of the carrier wave is varying in accordance with the instantaneous amplitude of the modulating signal, that is modulation. So in amplitude modulation, the amplitude of the carrier signal is varied in accordance with the instantaneous amplitude of the modulating signal. So AM is the amplitude of carrier is increasing or decreasing in accordance with the instantaneous amplitude or variations in the amplitude of the modulating signal. So the amplitude is changing. Amplitude of the carrier wave or the amplitude of the high frequency wave is varying in accordance with the variations in amplitude of the low frequency signal or the modulating signal. The frequency of the carrier remains the same. The main application of AM is broadcasting of voice signals. let's see the graphical representation of this modulating wave, carrier wave and the AM wave. So this is the modulating wave. Modulating wave means it is the information signal or low frequency signal or the modulating signal, or this is actually the information. So this is represented like this: positive half cycle, negative half cycle, again one more positive half cycle. This is the carrier signal. We know the properties of carrier signal. Carrier signal means it is a high frequency signal. Its frequency, phase and amplitude remains the same or they are constant. So in modulation, the amplitude of this carrier wave, in amplitude modulation, the amplitude of this carrier wave is varied in accordance to the instantaneous amplitude of this modulating wave. So this is the resultant or the output modulated signal. So we are superimposing this low frequency signal in a high frequency signal, gives the modulated signal or AM signal. So this AM signal is representing like this. So this carrier wave, the amplitude of this carrier wave is varied here. See, this Vc represents the maximum amplitude. This point represents the amplitude of the carrier wave. Vc represents carrier voltage, or this is the carrier signal. Vm represents modulating voltage or modulating signal. So this is the maximum amplitude of this carrier signal. Okay, this amplitude of this carrier signal is varied with respect to the instantaneous amplitude of this modulating signal. See, the variation is like this. So this amplitude is varying according to this variation in amplitude of the modulating signal. So this is the amplitude here, then amplitude here, then amplitude here. So these 3 points, we can mark these 3 points like this. This variation in amplitude of this modulating signal is reflected here. So during positive half cycle, the amplitude of the carrier signal is increased according to the variation in amplitude of the modulating signal. In negative half cycle, you can see that the amplitude of the carrier signal is decreased. Amplitude is decreased with respect to negative half cycle. Then again come to positive half cycle. These are the positive values. In positive half cycle, the voltage is varying or increasing. So here also the amplitude of the carrier signal is increasing. So positive half cycle, if you are considering positive half cycle, the amplitude increasing. If you are considering negative half cycle, the amplitude is decreasing. So this shape or AM signal is represented like this. This shape is also called as an envelope. So positive half cycle എടുക്കുമ്പോൾ ആംപ്ലിറ്റ്യൂഡ് ഇൻക്രീസ് ചെയ്യുന്ന രീതിയിൽ വരയ്ക്കുക. നെഗറ്റീവ് ഹാഫ് സൈക്കിൾ എടുക്കുമ്പോൾ ആംപ്ലിറ്റ്യൂഡ് ഡിക്രീസ് ചെയ്യുന്ന രീതിയിൽ വരയ്ക്കുക. അതല്ലെങ്കിൽ ഇത് വരയ്ക്കാൻ വേറൊരു എളുപ്പമാർഗമുണ്ട്. ഈ പോസിറ്റീവ് ഹാഫ് സൈക്കിൾ ഇങ്ങോട്ട് ആദ്യം വരയ്ക്കുക. അതിന് നേരെ ഇൻവേർട്ടഡ് ഫോമിൽ ഇങ്ങോട്ട് ഒരെണ്ണം വരയ്ക്കുക. then in between AM signal വരയ്ക്കും or variations in amplitude വരയ്ക്കും. സോ എങ്ങനെ ആയാലും ഇത് നമുക്ക് വരച്ചെടുക്കാൻ പറ്റും. സോ ഈ രീതിയിലാണ് AM വേവ് റെപ്രസെന്റ് ചെയ്യുന്നത്. Let's see the derivation of amplitude modulation. A carrier signal is represented like this. Vc of t is equal to Vc sin omega ct, where omega c is equal to 2 pi fc, where f is the frequency of the carrier. And the modulating signal is represented like Vmt, that is equal to Vm sin omega mt, where omega m is equal to 2 pi fm. F is the frequency of the modulating signal. Fc is very greater than Fm. So this is the output or the instantaneous amplitude of the modulated signal. So that is AM signal. Vam of t is equal to some amplitude into sin omega ct. Why sin omega t means the property of a carrier wave is changing with respect to the amplitude of the modulating signal. So this is sin omega ct. So this amplitude is equal to a letter A. So we need to find out this A. So A is the amplitude of the AM wave. So how this AM wave is generated? A modulating signal is superimposed into a carrier signal. So the amplitude of this modulated signal is equal to Vc plus Vm of t. That means the property of a carrier signal is varied with respect to instantaneous amplitude of the modulating signal. That's why we have taken Vmt, instantaneous amplitude. So Vc plus, what is Vmt? Vmt is equal to Vm sin omega mt. Take Vc common, 1 plus Vm by Vc sin omega mt, and Vm by Vc is equal to small letter m, where m is the modulation index. So this is equation number 2. That means A is equal to equation number 2. A means the amplitude, and this is equation number 1. So substitute this second equation, that means the value of A in equation number 1. So it is equal to Vc into 1 plus m sin omega mt into sin omega ct. So this is A. A is equal to Vc into 1 plus m sin omega mt. So that is Vc into 1 plus m sin omega t, substituted here, into sin omega ct. So that is Vc into sin omega ct plus Vc into m into sin omega mt into sin omega ct. So we know that sin A into sin B is equal to half of cos A minus B minus cos A plus B. So apply this equation in this equation, we will get the amplitude or the modulating signal Vamt as Vamt is equal to Vc sin omega ct plus m into Vc by 2 into cos omega c minus omega m t minus cos omega c plus omega m t. So this first term represents the carrier signal. This second term represents the lower sideband, and the third term represents the upper sideband. This diagram represents the frequency spectrum of AM signal. So, from the previous session, we have understood the basic equation for AM signal, and the equation contains lower sideband, upper sideband, etc. In this frequency spectrum, that is omega versus amplitude spectrum, we can see the lower sideband and upper sideband. It is represented like this, and this is omega c minus omega m, and this is omega c plus omega m. We have seen these two values from the previous equation. In RC coupled amplifier and its frequency response, we have calculated the equation for bandwidth. So bandwidth is equal to the frequency difference. So from the 3 dB point, we have taken 2 points, lower cutoff frequency and upper cutoff frequency. So upper cutoff frequency minus lower cutoff frequency gives the bandwidth. Likewise, bandwidth is equal to upper sideband minus lower sideband. So omega c plus omega m minus omega c minus omega m, and that is equal to 2 omega m. So this 2 omega m is the bandwidth of this AM signal, and the total power is equal to PC is the carrier power into 1 plus m square by 2, where m is the modulation index. So there are some disadvantages. The efficiency is very low. It includes more noise, poor voice quality, less operating range. So these limitations we can avoid, we can improve these limitations by the use of FM. That will be discussed in the next video.